Dear DSA students, we are so excited to be on this journey with you, and we want to say a big well done for your commitment and enthusiasm so far. Whether you have just joined or you have been learning with us over the past few weeks, we see your progress and we are rooting for you all the way. Now, we know there's been a bit of silence around the learning management system, and we sincerely apologize for that. But here's the good news. We have an update as regards the learning management system, and it is one you'll love. Some of you may have been onboarded on the previous LMS, but want to ask that you kindly disregard any previous link, platform, or communication concerning that old system. We are officially switching to a new platform that you may be familiar with, Canvas by Instructure. For those new to Canvas, don't worry. A video tutorial will be uploaded to guide you step by step on how to use the platform effectively on our YouTube channel. You will also receive an onboarding email directly from Canvas by Instructure to help you get started. Please follow the instructions in the email and input your details to begin your learning journey on the platform. We are committed to making sure your learning experience is smooth, interactive, and impactful. So please, pay close attention to the announcements coming right after this video for more details. We are so glad to have you with us. Keep going, we've got this.
Okay. Good evening, everyone. Welcome to class again. I hope you guys had a lovely week, a rest week. For today's class, we'll be discussing big O notation, and I remain Emigwe Chukwudi John, CTO, the Media Health. So I just hope you guys are ready for this class. And for those that have always been clamoring for practical, I'm sorry. This is not a it will be less of practical, it's more of theory. But believe me when I say this is something that will differentiate you from other developers, from other engineers. So it's something you actually need. Okay. So before I proceed with this class, I would like to ask some few questions. The last class I had, I asked those who can. I know the last class I had was more of revolving around database. Okay. I asked that as an assignment that you guys should go ahead and change the file system we had on the example that was shared by my other colleagues. We should connect that code base to a database instead. I don't know if anyone was bold enough to take up on that challenge. I'll just look at the comment section quickly. Did anyone give it a try? If I see one yes, I think I'm okay with that. Though even without that, I know I'll still proceed with the class, but I'm just saying. So let me also. Oh, you did cool. So you are already creating it like the LMS announcement you add. That platform will be used to access assignments like this very soon. So please, those that have done it, well done. Those that are yet to do it, it's not too late. Please find time to do it. The best way to learn is by challenging yourself. So you need to challenge yourself. So for those that did it, how did you feel after achieving it, or was it difficult? Did you find any, was it a bit of struggle for you, or you couldn't achieve it, or was it easy? Some are still asking to do what? So probably you watched the previous slide, but nevertheless, well done everyone. So for today's class, we'll be doing, like I said, big O notation. So I don't know if you guys are ready for this class. So can we proceed? Uh, for those that haven't done it, like say you can go ahead, you can still do it, you still have time for that. So can we proceed with the class, guys? Let's see, first session. So we can proceed with the class. That is good. So please, like I said, a lot of stories, but you need to listen because it will help you. Okay. So I'll be moving over to my first slide. So today we're doing big O notation. What will we cover today? So we're going to look at what is big O in daily life, common big O types, visualizing big O. So please, I see some people complaining about not having access to the LMS. You should have that soon. Please ensure you use it properly, because remember, from the onset of this class, we specified that 3 months might not be enough to cover a lot. But with that LMS, we will be able to engage you guys. You can check your mails properly, maybe your spam mails and all. You should see the onboarding link there. Okay. Then if you're having issues with that, you can drop a message with the chat stuff and all. So all assessments will be happening there soon, like I said. Okay. This slide will also be uploaded there. So far, all previous slides have already been uploaded on the LMS already. So the moment you have access to the LMS, the moment you log in, you should see the slides already. We have them there already. Okay. So we'll proceed with the class. So I've touched on what we will be covering today. So let's proceed. Yeah, slides are uploaded already. So can we proceed? I don't want to. It's too early to start losing people. I mean, in the course of having this class. So can we proceed? You will see the slides, don't worry. Can we proceed, guys? Just one? Yeah, cool. So let's proceed. So, I'm going to the next slide. Yeah. So learning objective. So by the end of this session, participants will be able to identify and classify the time complexity, which is big O notation, of simple JavaScript or TypeScript functions by analyzing code patterns, understand how different code structure impacts performance, build the habit of spotting common big O patterns in code, gain confidence in evaluating algorithm efficiency in practical scenario. So this is what you stand to gain from this course. It might not look like much, but believe you me, it will take you far. Okay? So I'm going to the first. What is big O? So I don't know if it's the first time you guys are hearing of big O. If this, so I want to make this class as interactive as possible to make sure I carry almost everyone along. So if it's your first time hearing of big O, I don't know the kind of big. I mean, big O relating to computer science, relating to software and data analysis. If it's your first time hearing of this, can I say a yes? Oh, it's your first time. Welcome, welcome, welcome. So I will try to make sure that I don't say a lot of jargons that might not apply to you. But believe me, the slides have been designed in such a way that it should make more sense to you. So don't worry. Let's proceed. So I will just read from what I have here, then I explain. So before reading that, let me just do a little quick story. Not really a story. So I want you guys to imagine 2 developers writing a function. I believe we all know what functions are now. Yes, we do. I'll be doing a lot of assumption for you guys. I believe we all know what functions are now. So imagine 2 developers writing a function to search a list. They were given an assignment to write a function to search a list. So one of the version the developer wrote crashes on big data, while the other one works fine. So what I'm trying to specify is this. you might be asked to do a task and that task actually works. Maybe when you test on your system with maybe small data and all. But there's high chances of when you test with larger data, your app breaks. So for instance, let me say you have a software that works fine with maybe 2 users using it. Then maybe when you decide you have had several friends to test with, maybe 4 or 5 people, your app was working fine, it wasn't crashing. Then maybe when you now decide, okay, I think this app is ready to go live, you decide to host this app. Then online, probably it's exposed to maybe over 100 and 200 users. Your app starts crashing. Then there is a problem. Okay, so that is the essence of big O. So I'll read from the definition. So big O is a way of describing how efficient an algorithm is in terms of time and space. When I say space, I mean memory, as the input size increases. So please take note of the definition. It's all about being able to predict how efficient your algorithm is. That is what big O is revolving about. So it doesn't even mention it doesn't measure actual time, but how space grow with inputs. So if you recall the problem I mentioned, the two developers, their programs, they were working fine. But when tested with more data, with big data, one of them crashed, while the other one was still working fine. So with big O, with your understanding of big O, you should be able to tell if your program can handle more data as efficiently without costing you more memory. Okay, it's like for instance now, it's like checking how long a recipe takes as guests increases. Okay, so you can picture so many examples because it's like your practical life. The more things, for instance, now let's say you are hosting a party, the more you have more people attending your party, the more food you want to cook, stuffs like that. Okay, so big O, understanding of big O, before I call it big J, your understanding of big O will make it possible for you to predict probably how long, like if I have XYZ users, multiple of users, what should my memory size look like? Is there a way I can make my program more efficient so that I don't spend more time on memory and so that my program does not crash? So one thing that will differentiate you from your regular developers out there is not just, I don't want you guys to be developers or engineers, as the case may be, of I've written my stuff, it's working fine. No, I want you to go further and ask yourself, is this the best way to do this? So the first way is to get it working. The next step is to ask yourself, is there any better way to do this? That is big O for you. Is there any better way? That is just the major summary of it. So I just hope we're all on the same page now. Have I lost anyone so far? Please, have I just using the chat session? Have I lost anyone so far? I believe with this little explanation of big O should be enough for us to carry on. Like I said, your class doesn't end here. It continues with you. You still have the opportunity to go on and do more research on yourself. All we are giving to you is soft landing, so it doesn't look scary for you. So good. So thank you. I'm going to proceed with to the next slide. So why do we need big O? I believe with the little explanation I've given so far, you're already getting a hang of why big O is important. Because programming is beyond something is working. If you want to be a good developer or a good engineer, you should be looking towards, apart from it working, is it efficient? Can it scale? If I increase the number of users using my products, will the app crash? These are stuff you should be looking at when you grow. Okay. So why do we need big O? So it helps you predict performance as data grow. I've already mentioned something like that. You focus on how fast or slow code run at scale. So these key things are important. Big O, somebody is already asking, are we done with backend? Nope, we're not done. Well, you can say in a way, but we are not. So what we are teaching you is not just backend, frontend. We are teaching you the whole software engineering process. Then if you going forward decide to specialize on maybe backend or maybe front end, That is on you. So big O is not like it requires coding. It's more of like what? An ability for you to check if your coding falls under a certain type, or what can you do to enhance it. So please just focus on the class. Okay, so let's proceed. So for example, I have a little example on my slide here. Searching for a word in 10 page versus searching for a word in 10,000 pages book. So the thing is this is just a little virtual. So just picture it. Let's say I open a book and I just pick a random word and I ask you to search. The volume of the book will determine how stressful for you to find that little word I ask you to look for. So comparing 10 page to 10,000 page, which one do you think will be easier to find a word? So you don't have to answer that. Obviously, it's going to be the 10 page. It's like saying the lower the number of users using your app, the faster your app will look like. But an efficiently done app shouldn't lose its speed and all with increase of users. So this is what I want you guys to be looking at, okay? So your computer generally gets slow when inputs go. For instance, now when you hear some people RAMs, you check your RAM usage, you are saying that it's getting high, or maybe your hard disk is getting filled up. Things like that generally makes your computer slow. So big O is a tool that describes performance. That is what you should know. It's not a case of programming languages and all. In fact, big O notation is more of even a mathematical term. For those that don't like mathematics, welcome. But you don't need mathematics for this course, okay? So applying big O to computer science, to programming, is you being able to describe the performance of your software even before you run it. Okay? So I'll be asked again, are we on the same page? Have I lost anyone yet? I'm not sure I've lost anyone yet. The flux I'm giving to me, I've not lost anyone yet, hopefully. So let's proceed with the class. I'll gradually be looking at my presentation and checking if there's any question relating to this. If I skip any question, please forgive me. I'll try to answer as much as possible. But I don't want you guys to lose focus of what is actually important, which is what we're studying today. Okay? So I'm going to proceed now. The next slide. So now I'm giving you big hole in real life. So I have various types of big hole by the side. We'll come back to defining what they mean. But for now, I just want us to picture something. I'll just be asking you which one do you think is easier? Okay, maybe I might not ask. So let's see. So instantly opening a bookmark page. So if you look by the side, you see O1. The O there is the big O. The one you are saying there is telling you that is a constant. So for instance, now let's real life scenario. I open my browser. Let me say I'm about to visit let me say Facebook. I'll probably need to click then type before Facebook pops up. But assuming Facebook is a bookmark, I added it to my bookmark. All I need to do is just to open my browser and click. And the moment you click on it, it opens. So that is a constant. It doesn't change. As far as I have Facebook on my bookmark, it's a straightforward click and it's opened. So in this case, we tag that as constant. I will explain that later. So we have O1 signifying constant. So somebody is saying we can use AI for the assignment. So for me, I don't kick again. So funny enough, there's high tendency that most of the problems you will try to solve in the course of this journey, somebody else might have encountered it. So there's nothing wrong going online. There's nothing wrong employing tools. But my problem is ensure you understand it. Ensure you understand it. So for instance, now if you use tools like Cursor, yeah, if you use tools like Cursor for programming and other several other tools out there, you type your problem, it gives you a code and all. If you don't understand the code, there's no way you can guide the AI. For those that are already heading towards AI, which I won't support, but if that is what you want to do, it's good, but it's fine by me. If you don't understand how programming really works and the code you are getting from the AI, you will just be stuck. You will not even know how to ask the proper question. So sometimes being good in programming is not just about coding, it's about understanding your problem. And when you understand your problem, you know how to ask the right questions. There are cases whereby you have a problem, you just don't know what to type, you just don't know what to specify on your browser that this is my problem. To solve that problem, you need to understand this thing properly. So if you're going to use AI, please feel free. Okay. So let me still stress a bit on the LMS. So okay, so I think we discussed that during break. So let's just proceed for now. So I've explained the whole bookmark stuff. It's easy the moment you bookmark something. So another example I have here is grabbing a cup from a cabinet. So there's actually no logic there. It's like you are keeping something on the table, you can easily grab it. It's a constant. It doesn't change anything. Okay. So the two instances I have there does not require any much stress. It's a straightforward. It's not going to change time. If I'm to work at the same time pace, let me say I keep something at the end of my table. I want to pick it up. I'm using same time. It's not going to change no matter how many times I do it. So hence, all these fall under O1. I'm going to explain what that O1 means later when we go further. Okay, but for now, just try to understand the whole logic. And please, I'm not teaching, I'm not probably lecturing you guys to carry terminologies on your head. What I want you to do is to understand what it means. Okay? There are some people that learn programming just to pass interviews. That is not who you are. You want to do this because you enjoy doing it. Okay? So I'm going to own a big ON next. So reading each page of a book from start to end. So take note of the difference. The first one are just one action. Okay. Now we're having reading each page of a book from starting to end. Assuming a book has, let's say, 20 pages, you're reading from start to end. I'm going to show you how this relates to programming later. So the next one is checking every paper in a stack. Everything. So that is for ON. But don't let this confuse you yet, okay? So let's proceed. So another thing is this. The next one we have here is log n. I might not touch most examples here because the next class you'll be having, you will dwell more on this. So what a log n does is more of starts in the middle and cuts the search. So imagine, let's say I'm looking for a particular word in a book. I can, instead of probably starting from the start to finish, which is like ON, I can just go to the middle and start searching from there. That is log n. Then the next one, I will explain all these things. These things are going to make more sense. The O is more of the big O, so don't let it confuse you, okay? Like I said, focus on the explanation, not on the terms, okay? Then the next one I have here is for each student asking every other student question. So just imagine we are all students here. Then every student here has a question for everyone here. So if you check all these things I've mentioned so far, some take longer than others. For instance, now the first one is faster, followed by the next one, like followed by the log n, which you are cutting into half, followed by reading everything from start to end, then followed by starting asking a student to ask everybody questions. So you will understand these things better when we move to the next slide. So don't let this confuse you. By the end of this class, I'm even going to ask you guys to think of any real life examples you feel you can apply big O to. Okay? So let's proceed. So I was mentioning O1, ON, N square, and log N. So O1 means constant. Okay? An example is more of the one we just see now, picking something from the cabinet or an array lookup, probably checking index, getting the value of a particular index in an array. Okay, so that is one. ON is linear, one loop. So if you remember, I was saying something of under the example of ON before this slide, from start to finish. From start to finish. When you hear loop, you are thinking of for, while, do, while, and all. So when you are hearing anything linear, it's more of a loop from start to finish. Okay, cool. So n square is quadratic. For those that did quadratic in secondary school, it's back again. I'm sorry, I can't do anything about it. So quadratic means is for the n square. It means nested loop. So what does nested loop means? It means a loop inside another loop, which is same as what the example I gave you. All students asking every other student questions. Okay, so that is a loop inside the other loop. So first of all, we have all students. Then each of that students now will now be asking every other student questions. So a loop inside another loop. Then the last one, another beautiful mass. For those, I won't apologize again. It's not my fault. We'll call it logarithm. You see, that one is even a problem. Logarithm, but then they make an up. So it's more for binary search. We have the bubble sort and all. For this, I won't be dwelling much on this. Why? It will be covered tomorrow. Okay? So I'm tempted to ask if there's any question, but I'm scared that people already start complaining. But let me just give it a try. Is there any question so far? Have I lost anyone? Have I lost anyone so far? Have I lost anyone? Okay, I'm assuming. Okay, cool. I'm assuming I'm not. Okay, cool. So let's proceed for now. Okay. So we're going to the next slide. So now we start explaining functions. So I believe with these examples, you might probably start understanding what big O is all about. So we are starting with the first one, O1. Okay, I'm not calling it 0. I say it's O because it's big O, which is what? Constant time. So I want you guys to look at this function. I believe this function is self-explanatory, but I'm going to explain. So will you send the slides for guys? No, no problem. You get the slides, certainly. You get the slides. Now that your LMS platform is working, is up and running, you'll certainly get the slides, okay? So don't worry. You don't have to know maths to learn programming. I'm just pulling your legs, okay? Before you run away. You don't need maths to know programming. At least I'm explaining everything so far. I'm just giving you guys flashback, okay? So let's proceed. Looking at this function, what does this function do? It gets the first element of an array. So look at this now. We have the function keyword, okay? Okay, do you know what? Let me go back. Go and learn small maths. My mind is judging, my heart is judging me. Go and learn small maths, but you don't really need. So the thing is what maths help you do is it probably helps you know how to solve one or two basic calculation. At least no board maths. No board maths at least. So let's proceed. So looking at this function now. Function get first element. Okay. So get first element is the name of the function, right? I hope you guys still remember how to write function. Please don't forget that. So this function is stating that it's going to take an array of numbers. I'm reading it for you, okay? An array of numbers. And the variable name is what? The argument name is ARR. That is array, okay? And this function is expected to return a number. I hope we are on the same page now. So now we're going into the function now. So please work with me because we're not coding any of this. They are very easy. I just want you to look at it. You need to get to the point where you can look at code and you can read it. If I call it lemma, you just need to look at it and it's making sense to you. Okay? You don't have to test it. So what does this function do? It returns the first element of the array. How is it doing that? It's calling array in square braces, the first index, which is what? 0. So now, if you guys, I don't know if you guys have had times to play with arrays, array and array indexing. So all arrays starts basically with 0 down to L minus 1, which L being the length of the array. So let me say, for instance, now, If I have an array of 4 elements, please don't forget an array is. We explained it in the previous class. If I have an array of 4 elements, the first element in the array will have an index of 0, the next will be 1, the next will be 2, then the last will be 3. So, okay. So if I'm to get the first element of this array, all I need to do is to call the first element by doing array, ARR, which is the name of the array, passing the index 0 will always give me the first element. So now look at this explanation I have at the bottom. This works instantly, even for a billion elements. So look, so no matter the length of the array, it's not going to slow down this program. Why? All this program is doing is just picking the first element. So that is why we call this one constant time, O1. Okay? So for instance, now if you are looking at real world scenario, opening the first email in your inbox. So it's not like you are scrolling down to look for a certain thing. You just open your mail and you open your inbox and you just open the first mail. That is a constant time. Okay? So I believe this one is clear a bit. Do we need further explanation of this or can I proceed? Let me look quickly at the slide, the comments. So for your attendance, you have that by 8 as usual. So please exercise some patience. So my question is, are we still in basis of programming? I almost called you my brother. You are beyond basics for now. In fact, you're already moving. Probably you don't know. So far, what you have learned so far is enough for you to start to pick up a mini project and start doing something. As far as you go, you ensure that you are pushing yourself to learn beyond this. Okay? We will still have the workshop session, but for now, just try and follow. Okay? So someone is asking me to expatiate on the array. Why you not just say, okay, I can't use paging. Let me calm down. Okay, I wanted to say that I just say explain. You want to add to the problem by using that word, but no problem. I will explain a bit on it again. So I don't know if you guys remember what. So if you before I answer your question, a few minutes. So if you have one key element, the array O ends at exactly term Dana. If I pronounce your name correctly, exactly. So that is it. So let me just explain. Array is a form of data structure that keeps same type. For instance, now this array is of type number, meaning everything in that array is going to be of numbers. Okay, if that is a confusion. So everything about this array is in this first curly braces. Then after the column, the number you are seeing there is telling you what this function will return. Okay. Then inside, we are just calling the first index, which is the array name, and the index 0, which is the first element of the array. Okay, so let's proceed to the next class. So let's proceed to the next class. So I will continue with the class now. And I always say this during my class: if you don't get this during the class, you don't need to be scared. Just find time to go over this class again. You should get it. If it's still not making sense to you, go ahead and research. Ask your peer. You should get it. If others are getting it, you will get it. Okay? So please let's focus on the class. So the next one, we're done with the constant time. The constant time meaning no matter the length of the inputs, nothing is changing. It doesn't really affect the executional time. Okay? So the next one is what? Linear time. So let's look at this function again and I will explain. I would have decided to just assume that we have pros here and we can understand it, but let's not do that. Okay? So let me explain this function now. So look at this. I have a comment. I hope you guys remember her. I'm not sure we mentioned, but comment starts with either you see the slash. You can search further on how comment slash. How comments are started, So what this simply means that the compiler or the transpiler, as the case may be, is going to skip this line because it's comments. So on our comment, we're already specifying print all items in an array. That is what we want this function to do. Okay? So now let's go through it. So we have function, which is a keyword, okay? We have print all, which is the name of the function. Now this print all is accepting an array input of numbers. I believe we're already getting the hang of this gradually. Then after it, we have a colon called void. I think void is an English word. So most of the keywords you have in your programming language, they are all English words. So in this case, void means it's not returning anything. If you check the previous example I had, we have returning array of index 0. It's returning something, and I specified that it was returning what? A number, okay? But in this case, void, if you look at this function, you will not see anything like a return because I've already specified void, and void simply means that this function is not returning anything. So with this function we're having so far, all we're doing is what? Writing something. They say print, so we're only printing something. How are we doing that? Using the what? Console.log. But let's take it one at a time. So let me assume that we understand what the functional line means, the function, the print, or the array number. Let me assume we understand that part. So now we are at the for loop now. Remember, we talked of for loop, we talked of for, we talked of while, we talked of do while. Under for loop, we have for off, we have for in. Yes, this is TypeScript. This is TypeScript, okay? This is TypeScript. So everything I've replicated here, you can also have it in maybe Java, JavaScript, and Pythons. That is dependent on you. But since you have started with TypeScript so far, I ensure that my examples I have over here, they are on TypeScript, okay? So let's proceed. So we are done with the functional parts. The function, the name of the function, the kind of parameter the function is accepting, and specifying that this function is not returning anything by stating void. Okay? So now inside the function we have a for loop. So let me read. We have const item of array. What does this thing mean? It means that loop through everything inside of the array, assume taking them as item. So in other words, everything inside this array, I'm going to treat them as item, which is this variable name we have here. Then we have console.log. I hope you also remember what console.log means. I'm begging you. So all we are simply doing is logging every item inside the array. So in other words, we are logging, remember the array is what? An array of what? Numbers, right? We are logging every number that is going to be inside this array. So nothing stops you for practicing this once you have the slide and checking with your code editor, calling the function and passing an array. Please try to do that on your own. Okay. So now if you look at this, let me give the explanation I have at the bottom. Time grows with the size of the input, which is true. In the sense of if the elements in the array increase, the time spent for this program to run will continuously increase. Unlike the case of O1. So in other words, the time it will take an array of 10, length 10 to run is different from the time it's going to take an array of length 1000 to run. You can practice this. Okay? So, for instance, now you can look at reading all the messages you have in your chat, which is different from deciding to just read the first message you have in your chat. So, how long you spend reading all the messages depends on the number of chat threads you have open. Okay? So, compare ON now to O1. O1 is constant, independent of the size. Linear, as the size increases, your loop, as far as you are looping through something, is dependent on the size. So try as much as possible. Now that I'm saying it, let me use it as a disclaimer, as a way of advising you guys. Try as much as possible to reduce the number of for loops, especially nested for loops or nested loops generally, a loop inside of a loop. Because all you are doing is increasing the time spent, except in the case whereby you can't avoid it. Okay? So let's proceed. Is there any question relating to this so far, or some people are already lost? I will quickly look at the chat to see if I can guide somebody back for those that are lost already. Is anyone lost? I'll take few questions now so that I don't yeah, we're going to touch example of next of the quadratic one. So just exercise some questions. Okay, I think I missed this in my slide. I missed it in my slide. So probably I will just write something quickly. I will explain it. You will get to see an example of it when we get to the mini test. Okay. So, is there any other question? Some people are beginners. Why not pair them in teams? I'm not sure that's my problem. I'm looking at questions now. Please, before I go too far, feel free to ask your question now. Feel free to ask a question now. Hmm. Okay, so I'm looking at the questions. I've already answered that this is TypeScript, so I'm not going to go over that. I'm going to skip that. So I think we are good. So let's proceed. So let me explain the for loop. I don't have an example here for now, but you will see an example when we get to the mini quiz. Okay. So the I said the for loop, the n square, which is the quadratic time. So just know that anytime you see a loop inside of a loop, you're already having n square already. And please try as much as possible to avoid such scenarios, except it's unavoidable. So, for instance, now you see the example I give about all the students we have here, which is already a loop already. Let me say I want to get all the names of all the students we have here. That is a loop already. Now, I need all the students we have here to ask every other person we have in this class their names. That is another loop on its own. So when you think of programming, try and picture it with the real world. That way it makes more sense to you. In fact, that is why we want to ensure that we explain OOP to you guys, so that you picture programming with real world items and all. Okay, but you will understand it when we get to the mini class. So that is for n square. Same issue as the size of the array is growing, is increasing. Okay, so but don't worry. This is not Python, this is TypeScript. But every example you have here can be replicated on types on Python or any other language you are used to. And please also know that as you're asking me questions and I'm doing my best to answer every one of them, be prepared for my questions, okay? We're going to do a lot of questioning today. So someone is asking me to explain the meaning of console.log. I would have asked someone in the chat to explain it, but let me see. So console.log, if you are probably present when we had our first class, is what we use to output something to the console. So when you hear console, console can be your terminal. Log is like you logging something. So what console.log will simply do is to print out something on the console. Okay? So you can, for more clarification, you can make reference to our previous videos. Okay? It's as simple as that. So I'm not sure there's any other question. Is it okay? Somebody, good Samaritan already answered that question. So since we don't have any other further question, give us some array examples to work for that function. Don't worry. Like I said, please find time to take this out and run. It's going to run, except you don't have faith. And I'm not having classes with people of no faith. Take this code and run. Okay? Once you get the slide, run. You can even watch the video, you pause and run it. It will certainly run as far as you have TypeScript properly installed. Then you know how to create arrays. You can refer to when we did data structure and all on how to define arrays. Define arrays, then call arrays inside the function. You should be able to run it. If you're having issues running this, please, you need to start going back to the videos and trying to, because we need your basic to be very strong. It's not all about covering so much, it's how far you can do well without further guidance. And by achieving that, your base needs to be very strong, which is what you are trying to achieve here. Okay. Okay, somebody is already using for it as English. You will get the attendance link later. So let's proceed. So I'm going to go to this log n, which is the logarithmic logarithm. The make is giving me a tongue twister. Time. Okay, whatever you are saying there, the time. Okay. So I won't explain this much because I might end up adding to your problem. And this particular slide is not too big for a reason because of I needed to cover the full content of the code. But let me try. I'll just try. I'll just explain it line by line, but I won't dwell further on it. Okay? You don't have to understand this, but you understand it tomorrow. So we have a function that does binary search, like searching for a certain item in an array. So it takes into inputs, it takes in an array of numbers, and it takes in a target, which is the number you're looking for, and it's returning what? A number. The number is returning is the index position. Yep, if I'm not mistaken, yeah. Should be the index position of the array, of the element in that array. If it's not found, it's going to return -1. I'm just going to read through the code base. So the first thing is to define a lower limit of 0. Then we set a higher limit of array.length -1, which is trying to get the last index of the array. Then we did while low is less than high. We're using the while loop here. Then we set a constant called middle. Then we do math. Math is a function. Almost all programming language has some libraries. And I think, yeah, either I think Busola or Deji already mentioned it, installed in them already that you don't need to import. So by virtue of having TypeScript, math is already part of it. Okay. So when you do math.floor here, it's like taking the seal of a number. For instance, now, for those that say if math is not required, I'm sorry, this one is relating to math a bit, but let me explain. I'm just explaining the code. You don't need to get it now, okay? But you will get it tomorrow. You understand it tomorrow. But let me just explain all the terms here. Attendance is from 8, okay? So please exercise patience, okay? So math floor. Let me explain what floor means. There is if you remember your basic maths, it's not like I'm here to teach you maths, but you need it in this case. If you remember your basic maths, let's say you have something of decimal. We have what we call round up, and we have seal, and we have floor. Round up, seal, floor. When you are rounding up something, they can tell you round up to the nearest one decimal place, two decimal place, stuff like that, something like that. Okay. So now, floor is telling you. Let me say if I have something of 6.5. If I'm to get the floor of 6.5, I will get 6 as a whole number. But if you are looking at round up, anything close to 0.5 should take you to the next number, which is 7. For those that still remember, okay? So floor will give me 6. Why seal? That is CIEL, yeah, ceiling, like your ceiling, will give me 7 if I'm looking at a number like 6.5. So same thing like 6.2. Floor will give me 6. Seal will give me what? 7. Even if it's close to 6.9, floor is always going to give me the lowest one. Why seal will give me the upper one. So that is just what this function is doing. So now we're taking the average of low plus high divided by 2. That's what that line is doing. Then we check if the index on the mid number we get, if the input we are looking for is available there. If not, we return the mid. If it's available there, we return the middle number, which means we have found that index. S, if it's less than the target, we perform a computation low equals to middle plus 1, S high equals mid minus 1, S if not is found, we return what? -1. So all I'm doing here is just explaining each of the line. Yeah, you can't see the screen clearly, don't worry, I'm sorry about that. The codes were much and I needed it to be contained here. You will see it when you get the slide. All I'm doing is just explaining the lines. I'm not explaining it for it to make sense to you because you don't even know what binary search means. I'm assuming some of us don't know. Okay? But when you know tomorrow, you can go back and look at this when you get the slide. Nonsense to you. We proceed. I will not ask if is there any question, but please not question regarding this. Can you guys hear me, please? Okay, cool. So can we proceed? Can we proceed? So, like I said, you understand this log n from tomorrow. But so far, is there any question? Or we are tired already? Is programming too much for us? Or are we considering changing to another course? It's too late. Okay, cool. So I think we can proceed. So let's proceed. So you say let me look at okay, let me just look a bit on question. So you say the floor of 6.5 is 6 and this veil. I don't say veil, I say seal is 7. What are the floor of 6.2? The floor of 6.2 is 6. Why the seal will be 7? So the way floor and seal operate is not like your round up, it's different. I believe the one you are used to is more of round up. The floor will always take the bottom, seal will always take the top. Okay? Okay, break it down to us as well as see how we can resolve. Some of us are not getting explanation. Yeah. So, please, if there's any place that is confusing to you, please just drop a message. And since we will still be engaging you guys now that we have our LMS platform is up and running. So, in some way, the class doesn't end here. We'll still be chatting. What ends here is the video. Okay, is the live session of which you can still go back and rewatch the videos. Okay, programming is not like it's not like picking one basic thing easily. It needs time. It needs time. It needs dedication. It needs commitment. It's like you guys are turning me to more of an advisor than just teaching you guys. So please, it's not going to be easy. It's not going to be easy. And don't be discouraged when it looks like everyone around you is already understanding it. You can. You just need to give yourself time. That is why we started from the basics. And everything I've been teaching you so far on Big O is not just pertaining to programming. The Big O still applies to other parts. We still have Big O in data structures and data science and all. So it's not even tied to any specific programming language. Okay? So please just take your time. It's not gonna be easy, but you will get there. And we will still have the workshop session, which I'm looking forward to, whereby it will be our turn to ask you questions to see how far you have progressed. So for now, focus on understand this basic stuff. In time to come, you understand it better. For me, it took me, let me not start saying my own problem. It took me 3 years, if I'm not mistaken, before this thing starts making sense. Probably because I was not getting the right person to point me towards the right direction. But your case is different now. You have good guys to point you towards the right direction now. So it might not take you that long. So don't worry. Okay. So I'll be looking through if there's any question relating to this. For attendance, we'll be taking attendance by 8. Since we're already talking on attendance, let me use the opportunity to talk on the LMS a bit. So please, for those, you are advised that you check your mails. You can look for an invite from Canva, which is the name of the platform we're using for the LMS. Okay, I will come to that. LMS. Then you accept the invitation and set up the profile. So you can check probably the mail didn't drop properly on your inbox. You can check your spam box and all. Then if you check all this and you still didn't get the mail, please reach out to the admin. Okay. So I have someone is asking a question. I already have issues managing CPU as a developer side. Are we discussing CPU here? But nevertheless, except you're making reference to memory, let me assume that that is that. So somebody is saying, I don't understand this block of code. Yes, I already told you from the onset that you will not understand, except you have you have already understand what binary search is, of which you don't, but you will by tomorrow. By tomorrow, we'll be doing various types of sorting. Okay, sorting means arranging, sorting and searching. Okay, by then we'll expose you to the types of search. You'll be seeing binary search. You'll be seeing bubble search. There will be seeing the various type of sorting as well, which is arrangement. I think we have merge sort and leaf sort and some other stuff and all. For now, I just have this example here to let you know that something like this falls under log n. Okay. So for those that can't sign up on the LMS platform, we see your messages. We'll reach out to you most likely. Yes, you will be. Well, for the videos, I can't really say for now, but all materials you should be able to access from there. I think you can still go and watch all these videos from YouTube as well, if I'm not mistaken. You can. You should be able to. Okay. So I think there's no much questions for now relating to this. We go further now into the class. So can we proceed? Can we proceed, guys? Or is there any question you want to ask? I'm trying as much as possible to keep everyone intact. Can we proceed? Just one yes, we do. Okay, yes. So I've gotten one yes. So we proceed. So we go to the next slide now. So mind you, we've already explained n. We'll explain constants, right? Constant time. We've explained which one was that? Linear time, which is n. We have explained, I'm not calling the own, I'm just calling the numbers inside the braces, which is the first one is constant 1. The next one is uh, n, which is linear. Then the next one is n squared. I don't have an example here, but you will see example in the quiz. When you sit in the quiz session we will be having today, you will see an example of n squared. Now I've also showed you log n. So there are still others apart from this, but they are all combination of this. So for instance, you might say a case of n log n. We'll also be sharing a link with you where you can go and see various types of big O depending on the function you are doing. Okay, so but this is enough to guide you. Like I said, somebody is still making reference to n squared. So let me answer the question from DDG first. Ceiling 6.0 is 6. So you're already calling it 6.0 as far as that 0 is not up to 1 and it's still in 0. 6 is 6, whether ceiling or floor, 6 is 6. 6.0, I mean. So the next question I see here is, please, the test script is giving me some kind of error. Yes, you can use another language. If you are familiar with C#, please go ahead. Okay, but just make sure you understand the logic. Like I say, programming languages are just syntax. We might end up doing TypeScript today. You say no, what I want to work with is more of JavaScript. So please. Social media. So I think that is that. So I did expatiate on the N2. I didn't expatiate on the N2 because I don't have more. What I have more of an N2 is equation, but I gave you a keyword for N. For constant of 1, there is no loop at all, right? For n, there's one loop. For n2, there's a loop inside of a loop. We'll see that, don't worry. Just take note of this. Then for log n, they're just for weird algorithms like binary search and all other stuff. Okay? So Uh, yeah, for sure, the canvas. So, few minutes. So we'll be going on break by 8. That is in 2 minutes time. So instead of watching this, I'll just see if I can just answer some questions relating to what we have done so far. So class asking class, thank you. That is N2. Please tell them. Um, you know. So few minutes, yes. So I'm looking at the questions before we go on break. So I don't watch this. So is there any question now before my code editor can't do TypeScript? So if your code editor is not working with TypeScript, do you have Node properly installed? Do you have your TypeScript package properly installed as well? Are you saving your code properly with .ts like the examples we have had? Are you calling the right commands to transpile before you run the JavaScript version? Please follow all these guidelines, okay? If you are still lost, you can make reference to the first TypeScript program we wrote in one of our classes, okay? So I think I'm not seeing any question again. So I think it's safe for me to understand that everyone here understand everything I've been saying so far. I think I'm going to use someone as a witness here. Don Kendre, you're going to be my witness here. I've been asking so far if there's any question and they all understood. So we'll be going on break now. When we are back from break, we'll continue the class. Thank you. Okay. Welcome back, guys. I believe most of us should have done our had our attendance by now. So let's proceed. So for those asking for n square example, so we have a very beautiful one here to study. Okay. So please listen carefully. So the essence of this slide is converting a code which is at n square, that is in terms of that is quadri time, to what? To n, which is what? Linear time, which is what? Saving more time and more resources for your system. So look at it now. So I have even a comment saying inefficient way o n square to check for duplicate. So what does this function do? So this function, the job of this full function you are seeing here is just to determine if there is a duplicate in what? In an array. So let's go through it. I hope you guys are with me. Can we proceed now, please? Can we proceed? So I think we can. Uh, yes, yes, we can. So okay, please let's proceed. Okay. So please pay proper attention to this. I don't want us to do a lot of repetition because we have where we're heading towards. So I start. So look at this. So this is a function. The essence of this function. Don't forget the essence of the function to determine if there are duplicates in an array. So when you say there are duplicates in an array, what does it mean? Multiple occurrence of a particular value, maybe number or string, depending on the type of array. In this case, we are working with numbers. So let me say if an array has the number 2 twice, this function is supposed to return what? True. That is the essence of this function. So let's look at how we solve it using the quadratic time. That is the n square. So please, for those asking for an example of n square, this is 1. So let's go. So if this is a function, just work with me. The function we have slow has duplicate as the name of the function. Okay. This function takes an array of numbers. We should be used to this by now. And mind you, hope the array I'm saying, how do I know it takes an array of numbers? It's not because of the variable name, which is ARR. It's because of the open and close rectangular braces we have. That's how I know that this function takes an array of numbers. Okay, so this function is returning a boolean. If you guys recall what boolean means, true or false, yes or no, 1 or 0. Then in most cases, programming is true or false. Okay, hope I've not gone too far. Are we okay with that line? I'm assuming we're okay with that line, but please, I might end up explaining this and it will not make sense to you except you practice. So somebody is saying, can we use J? Can we use it for let? Yeah, we are using for let here already now. So maybe you need to look at your questions and a bit, it's not a bit direct. Maybe you want to rephrase your question. So let's proceed. We are done with the first line of the code now, and then we are going to the next line, which is the first for loop. So now if you take note, this for loop starts at line 3 and ends at at line 8. Is that where it ends? No. Let's see. This is 3, 4, 5, 6, 7, 8, 9. Ends at line 9. That is where the first for loop ends. Okay, so look at what it does. So it takes let's look at the arguments in the for loop. So the first thing we had is the initialization. Let I equals to 0. That is 1. Then colon. Then we have I less than array dot length. So we are setting this as our condition. In other words, let this loop not go beyond the length of the array. As far as this value we have here is less than the length of the array, this loop should continue. Then we have I plus plus, meaning increment by 1. Remember, I told you guys that we can also have this as I equals to I plus 1. And another thing I want to state, take it as an assignment. We have pre-increment and we have post-increment. What we are doing here now is post-increment. Go and research on pre and post. Take it as a mini assignment, okay? So don't, it's not important for you to do, but if you can have an understanding of it, it's a plus for you. So let's proceed. So we have explained that this first for loop is ensuring that it doesn't run beyond the length of the array. So first we are starting at I0. We're ensuring that I is less than the array.length, which is the length of the array. Array.length. Array is the array that we're expecting as an input, right? Dot length is a function you can call on any array. It's a function and it will always give you the length of that array. In other words, now if we have 4 items in an array, dot length should give you the number 4. If there are no elements in an array, dot length will give you 0. Okay? So let's proceed. We have explained the first 4. Is there any question on that or can we proceed? Is there any question on that? I'm looking at the comments if there's any question regarding this so I don't confuse you people more. So I'll just give it maybe a minute. If I don't see any reply, I'll assume we are all good, then we can proceed. Cool. So I think okay, they say I should repeat again. Let me try. Okay, so I start. Let me ask you a question directly. Okay, let me just go ahead and repeat. So please listen this time around, okay? After this, I'm not sure I will repeat this again, please, okay? So the first line is a comment. It doesn't run, right? Inefficient way. It doesn't run. So let's focus on the coding aspects, okay? So now we have function. Function is a keyword. We're writing a function that is going to check if an array has duplicates. That is what we're doing. What we're expecting of this function is if an array has duplicates, return true. If it doesn't have duplicates, return what? False. First, understand that that is a problem we're trying to solve. Now let's go to the code. So we have function. We call this function slow has duplicates. It's a slow version. Or you can just call it has duplicates, dependent on you. Okay? Then we have this function, and mind you, is checking for duplicates in an array. So meaning it must accept an array. In this case, an array of what? Numbers. Then after the colon, we have what we call boolean there, which is a keyword. So what this boolean simply means is this function is returning a boolean value, either true or false. And if you check at the boolean values we have here, we're either saying true or we're saying false. Remember, we also, in the previous example, we saw void. Void meaning there's no return, right? We also saw number, meaning it's returning a number. So depending on the type we have here, that will determine what this function is going to return. Okay? So now I'm going to the next line, which is the first for loop. So this for loop starts at line 3. That is, I'm counting the comment line as well as line 1. It starts at line 3 and it ends at what? At line 9 before the return false. Okay? So this function, this for loop, we reiterate, we have let I equals to 0. We are creating a variable and we are saying that the value is what? 0. That is the first thing we are doing. Then the next thing we are doing is a condition. We are saying that this for loop is going to run as far as I is less than the length of the array. So array.length, the dot length is a function on arrays that will always give you the length of an array. Okay? Then after that, we have I++, the incremental, or in some cases, the decrement. So mind you, it's not every time you might want to increment. Some cases you want to decrement. That is dependent on you. But in this case, we're incrementing. Because if you are to decrement in this case, of which I want you to try to your end, this loop will not end. So look at it now. I is 0. Let me say our array has 4 elements. We want this loop to run as far as, sorry, let me go back there. We want the loop to run. Yeah. We want this loop to run as far as I is less than the length of the array, which is in this case, I'm assuming 4. So if I'm incrementing the I, this loop run 0. The next time I'm running the loop, I'm adding 1. You check, is 1 less than 4? No, it runs. Then it goes back again. The I plus plus works again, meaning adding 1 to 1 again, meaning 2. Then it checks the condition, it's 2 less than 4. It proceeds. It runs. 2 is obviously less than 4. After running everything inside the for loop, it increases again to 3 by 1. It check, is 3 less than 4? Yes. It continues saying gets to 4. Is 4 less than 4? No, 4 is equals to 4 in this case. That is when the for loop will end. So this might not make much sense to you, but please find time to go through this thing later. Okay, you will have access to the videos. You should be able to search for these videos on YouTube even without the LMS. Okay, so let's proceed. So now another for loop, which is our n square. We have the first for loop that starts at line 9 and ends at what? Starts at line 3 and ends at line 9. Now we're having another for loop that starts at what? Line 4 and ends at line what? Line 8. Meaning a loop inside of a loop, and that is what we call nested loop. So I need you to try as much as possible to avoid nested loop, except when it's unavoidable. Okay? Because it grows rapidly as you increase the size of inputs. So look at the next loop now. The next loop now is doing this. For let j equals to I plus 1. J is less than, j is another variable different from I, but we are basing the value of j based on the previous value of I. So for instance now, if when we enter the loop I is 0, j will become 0 plus 1, meaning j will start from what? 1. Right? So now we're still saying that j should run as far as it's less than the array length. I'm also incrementing j. So now I want you guys to picture this because I need you to get to the point where you can look at code and you understand what is happening. So the major thing during the check of duplicates is the if you have in this function. So you can see the if that is telling you if I, array I, is equal to triple equals to, meaning both in type and value, is equal to array j. The array I is meaning the index of I. So I want us to play this together. Let's say in the first instance I is 0, right? J becomes 1 automatically for the first loop of j. This function is going to check if the value we have at 0, index of 0, is same as the value we have as index of 1. If it's true, it's going to return and this loop will stop. It's going to exit this function. So, but if it's not true, it's going to go back to the loop again. J is going to increment now to 2. It's going to be now array of index 0 is equal to array of index 2. It's going to continue. It's going to compare the index of 0 to index of 3, index of 0 to the index of down to the last index of that array. So what this function is simply doing is comparing every element one by one with other elements. So let me say we have 0 down to 5. It's going to compare 0 to 1, 0 to 2, 0 to 3, 0 to 4, 0 to 5. Before this for loop is going to end. So this for loop will only end if this is equals to true or is done with the full condition. So if it's done with the full condition, it exits and go back to the upper for loop. Now either is 0 will now become 1. So it now become a case of is 1 equals to 2, is 1 equals to 3. It stops like that. So please find time to execute this on your own. I don't know if I've ended up confusing you guys, or I don't really know, but I'm hoping that some people get an understanding of this. But even if you don't understand it, please find a way to run this. And if you don't run this, we will always reach out to it. We'll always have a conversation via the LMS going forward. We can chat, you can drop your questions and confusions over there. Okay, we'll be engaging you guys. So if after all this check and none of them returns true, we have the return false at the end, meaning there is no duplicates. So now if you check this full implementation, we had two for loop. Already is an n square, right? Quadratic. We have to loop through every element one by one, one by one. It's like the example I give of students. We are all students here. I want to know all your names, and I still want all the students here to know all the names of everybody in this platform. That is n square. And please try as much as possible to avoid it. So in the next slide, I will be showing you how we convert this to n. Some of the keywords you see might not make sense, but don't worry. You will grab all these things in time, very soon. In time, okay? Just make sure you're always practicing and researching. So let's proceed. So going to the next slide. So now we are using what we call sets. I know some people will be saying, we are just trying to understand array. Now they are calling sets. I'm sorry, you're the one that wants to learn programming, so please start getting used to this. We are still on optimization though. So the first one I explained so far is unoptimized. Now I'm explaining the one that is optimized. So the first one will obviously give you, you will find yourself with time, don't worry, okay? I'm sorry. The first one we just explained before now, which is this. We work fine. We definitely tell you if there's a duplicate or not in an array, okay? But I'm telling you that there is a better way to do this that will avoid this double for loop. Okay, so always see double for loop as quadratic time. Okay, then single n is your linear. So let's go to the next one. So in this next one now, we are using what we call set. So what does set do? I will explain what set do, and I will encourage you guys to go and research on set on your own. So we didn't touched on it as a data structure, but the thing is this: as you encounter problem, you start researching on, set is a kind of array. I'm coming, just give me time. As you encounter more problem, you do more research, you grow. We can't teach you everything. It's how well you push yourself to solve problem that will differentiate you from others. Okay, you will get it. Have faith. Go and watch the video again, okay, and do some research. So don't worry. Okay, it's like I'm encouraging a lot, but I know you will get it. That's just the funny thing. So you can't recall when you look back at all these classes and you will smile. So don't worry. So let's move on. What is a set? So a set is a kind of an array, but the difference is set automatically ensures that everything it has is unique. So for instance, now if I'm to create a set from an array that has duplicates, automatically that set is going to make sure that it removes that duplicate. It's going to be unique. So set always contains unique number. It looks like an array, but the difference is you can't have duplicates in it. So let me go through the codes. Like I say, it might not make sense to you, but just play along, then find time. It might not make sense to you today, maybe not even tomorrow. But when you give it time and you research further on it, when you start playing with various data structures, arrays, sets, tuple, you will get the hang of this. So let's proceed. I'm going to explain this same way, but I won't spend much time on this because it's like those that were following me already we're already losing them. So don't dwell on this too much. Just ensure you know how to tell what kind of O a particular function or algorithm is operating under. Is it constant? Is it n square? Is it n? Is it log n? Focus on that. Then you can get to understand more data structure later, more ways to perform stuff and all. So I'll give you an instance because it's not just all about writing code. So for instance, now when you go to people that repair phones, I just want to use this analogy. You go to people that repair phones, there is very high tendency, especially for those that probably buy phones from platforms like maybe AliExpress or maybe a new phone provider and all. There's high tendency that your phone, maybe the phone charging port is not working or something. That your phone, they have not opened it before. But when you watch these guys, the way they open this phone, it's as if they were part of the people that manufacture the phone. Why? How do they do it? There are already some set of instructions they have configured to themselves to know what to look out for when they are assembling any phone. And I want you to see programming that way. Once you have a problem, you're looking at, okay, what is the first step to do? Okay, the first of all, this programming, what is the problem am I trying to solve? And what am I returning? Then how do I go about it? Will I need a loop for this? Stuff like that. So when you practice this over time, you get used to it. So let me look quickly at just one question. So why does the array stuff use slow duplicate? So let me explain. In fact, you know what? Let's no need to explain this much. I'll just focus on the major difference. If you notice this, over here in this optimized part, we have just one for loop, right? If you look carefully, focus on that. You can leave every other part to your understanding later. I've already explained to you that set ensures that it stores unique numbers, right? Cool. So if you notice on this, we have just one for loop. And remember, I told you one for loop is equal to what? One n. If you have a for loop inside of a for loop, that is when you have your n square. I already know that by virtue of that, even without running this code, this one will always run faster. So let's continue. I'll just see if I can explain this. Glad you don't need to understand it, but just follow with me. So we have the for loop of first we create a new set. We want to store unique numbers there. Then we check, we loop through the array. I'll explain fast. Then we'll check if same is a set, has that number in that array. If that number already exists in that set, we return true. Else, we add the number to the set. As simple as that. Then if after going through that loop, we return false if there's no return of true. So you might not understand this now. If you notice, I'm taking it a bit fast, but you understand it with time. Okay? So I'm going to proceed to the next class because you guys have been doing the questioning ever since. I think it's my time to start asking questions. I hope you're all ready. I've been asking most of your questions, at least the ones I can answer. Now is your turn to answer my questions. Are we ready for this, please? So, see if set. So, yeah. Assuming it's a case of, let me answer your question, Mr. Joseph. Assuming it's a case of they want you to return all the unique values in an array, you can simply just create a set of it and you get all the unique values you can convert back to an array, something like that. But they want you to return either true or false. Don't forget that if it contains. So that is the essence for the whole loop and all. So, but if you take your time to study that code, you understand it. So it's my time to ask questions. I wish I could simply ask somebody to explain each of these functions we have here, but let's see. So we have a function here that gets last. I don't know if you guys can look through this function and understand what it does. If you understand what this function does, can you just type a yes? Do you understand what this function get last? What does it do? Yes. Okay. Is there any no? Yeah, the first function returns the first. Good. So now the first function we did returns the first element, right? Now the last one is returning what? The last element. As simple as that. Cool. So we have a get last. It's returning the array dot length minus one. Let's leave that. Now my actual question is this. What kind of big O is this? I've showed you. Oh, so I'm already answering. Please calm down. So what kind of big O is this? I need everyone to be on the same page. What kind of big O does this fall under? Is it constant? And I don't need 1 or 0. I need you to give me the actual name and the value. Don't just type O1. What is O1? So is it constant? Is it linear? Is it quadratic? I think I'll be focusing around those three. Constant time. So do we all agree that it's a constant time? Does anybody has a contrary opinion to this? So someone is saying linear. So this is not linear. Mind you, for it to be linear, there must be a loop. Is there any loop in this function? No. So it's constant. Okay, look out for that. Is there a loop? Then you are looking at n. Is there a loop inside of a loop? You are looking at what? N squared. If there is no loop, it's just a straight function from top to bottom. It's what? It's a constant. Okay? So now, the second function now. Are we all okay with the first one? Can we proceed to the second one? Please, we need to make sure everyone is following. So please, let's take it easy for others, okay? Can we proceed to the next one? Is there any question on this first of all? Any question on this first of all? Before I proceed. Is there any question? I think that yes is for us to proceed. But is there any question? I believe this thing is beginning to make little sense to some of you. I'm assuming. So is there any question? Any question going? No question? Cool. Let's proceed. So now we are looking at the next example. Can somebody just quickly look at this and tell us what is this function doing? Like the function name is even, right? Yeah. So what are we trying to achieve from this? Yeah, one loop is for linear, nested is for n square. Nested is for n square, not logarithmic. The logarithmic stuff is more for binary search and or which we will do tomorrow, okay? So I won't be giving examples on that for now. So what does the second function do? So let me read the example, the explanation for Peter. So the second function returns true if the number is even and false if it's odd. So first of all, before I even do the whole even and odd, hope we all remember what odd and even numbers are. Let me start from that. So you need to understand the problem first of all. Do you remember what odd numbers are and what even numbers now? For the sake of those I can't recall. Even numbers are numbers that when you divide by 2, you don't get any remainder, right? Why that is the simple basic definition. Why odd numbers is when you divide by 2, you get remainder of 1. So for example, even numbers we have 2, 4, 6, 8. Yeah. Don't worry, I'm explaining it already, Daniel. That is even number. Then odd number, we have 1, 3, 5, 7. That is odd number. See, I've helped you remember. So now that you remember odd and even, does anybody remember what prime numbers are? It's not part of this. I'm just asking. Let me not distract us. Let's just focus before I ask our problem. So we proceed. So this function is going to take a number and return true. So now see the first case now is returning a number, the first function of get last. But this case is returning what? A boolean, which is either true or false. So now, for some of us, the function inside here might look confusing. I will just explain. So what this function does is n is the number you are taking in, right? This percentage sign you are seeing here, we call it modulus. All it does is return remainders. So for instance now, we have n modulus 2. So 4 modulus 2 will always give me 0. Why? Because when you divide 4 by 2, you get 0. So let me take the number up. Let me say 5 modulus 3. I will get a remainder of 2. Let me say 10 modulus 3. I will get 1. Why? Because I can get 3 of 3 is in 10. That's 3 times 3 is 9. Then 10 minus 9 will have 1. So what this percentage symbol does is return remainders. Okay. So now we are asking you now, if n modulus 2 is 0, 0 equals to 0 is true. So that is just what this function is doing. So it checks if a particular number is even. So now my question, I just want everyone to understand everything. Now my question, what kind of big O is this? Where does this fall under? So where does this fall under? I'm looking at the comment section now. Where does this fall under? So function 2 is stay constant. Why they making me get plenty English? So in summary, you are saying it's constant. So I see a lot of constants. I see linear. So I'm still going to stress on the linear, but let me see, get some people's reply. I see constant. I just hope you guys are not guessing. So if it's linear, why is it linear? Remember what I stated. For something to be linear, there must be a for loop. A loop. It doesn't have to be for. There must be a loop. So in this case, do we have any loop here? Do we have any for, or do we have any while? Do we have any do while loop? No. So as far as we don't have any loop here, this falls under what? Constant. So just have that clear definition in your mind. No loop is constant. Are we clear? I just hope I'm not confusing you guys more. No loop constant. No loop constant. Just get used to that. No loop constant. Cool. So now we are looking at the next function now. Can we proceed to the next one? I won't be explaining much again because I will try as much as I can so we don't get distracted. Are we ready to look at the next one? Is anyone lost? Is anyone lost? This is the best time to pick you up. At least with all these examples, we can easily explain what I've been doing so far. Is anyone lost? I'm not sure. I'm not sure. You're happy you're understanding. Clap for yourself. So, like I said, it's not actually difficult, but I believe you understand it with examples like this. So, let's proceed. So, now the next one, I'm expecting this one to be very easy. And mind you, you don't even need to understand the full logic of this programming for you to get it. You don't need to understand what the code is even saying for you to get it. So, but I have a feeling that many of us are going to fail the next one. It's not like it's something I want, but it's what it is. So the next one, can somebody try and understand what we are trying to do here first of all? Can somebody just explain maybe on the comment section? What are we trying to do with this? So let me look at the comments. So does function 2 return? Yeah, function 2 will return even because 2 divided modulus 2 is equal to 0. So it's going to return even. Okay, 2 is an even number. So it takes a number and returns the number multiplied by 2. Okay, I like that in a way, but you need to take note of something. What is the data type that this function is returning? Is it returning a number or something else? This function is returning more than just a number. Look at the function carefully. What is this function returning? I need you guys to help with that. What is this function returning? I just hope I've not lost anyone. I'm looking at the comments. Calm down, calm down. So I'm already giving answers. Is returning an array of numbers. Thank you for that. Thank you, Olabi. So this function is taking an array of numbers and it's returning an array of numbers. So with that, you're already trying to understand what does this function do. So I know many of us have not used the word map before. But what this thing simply does is it's going to take an array. It's going to create another array one by one. All the elements in the array, their values, multiply it by 2. So let me say I have an array 1, 2, 3, 4. If I pass it through this function, it's going to double everything inside the array. It's going to become what? 2, 4, 6, 8. Okay? If I have an array 10, 20, 30, 40. If I pass it through this function, it's going to return, what did I even call safe? Think 20, 40, 60, 80. So it's not returning square, it's returning times 2 of everything. So that is what it does. So take note of the map. So you use this map. This map is an array function. You can use it to loop through all the elements in an array. So now take note of the words that I'm saying now. I'm saying the word loop. I'm not even saying for loop. I'm not saying while, but I'm also mentioning loop because this function is doing that for you. So with that being said, What type of O is this? What type of O is this? I'm looking forward to your answers. What type of O is this? Okay, somebody say linear. Okay, color say linear. Some say quadratic. Some say linear. Some say quadratic. Some say constant time. I will flog some people here today. But let's continue. The function is linear with big O of n. Okay. Some say quadratic. Okay. Some say on square. Okay, so I already know we are talking of. So I'm still looking forward to more answers to make sure that I carry everyone along. So we have constant, we have linear, we have quadratic. So what do you guys think we win this? This our beautiful ballot. Is it linear? Is it quadratic? Is it constant? Linear. Linear because it has one loop. Okay. Linear of one loop. Okay. Not nested. Okay. Definitely. Some are even certain. Definitely linear, quadratic. Okay. I think that is good enough. So this particular function is linear. Why? Because there's one loop. So mind you, I know I mentioned that if there's no for loop and all, but those are not the only type of loop. Some data structures have some loop functions embedded to them or to them. For instance, now you see this array map. It's going to pick every element in the array once. So by the virtue of it running once, running the loop once, meaning this is what linear. Okay. So I just hope those that are saying quadratic and constant are on the same page with us now. So this is definitely what linear, okay? Because it has just what one loop. Even when we're not using the for or the y and the do y that you are used to, we're using something we call array map, which is why I explained what it was before I asked the question. It's looping once, okay? So some say I should repeat. Array.map. Map is a function of array. Remember, I've touched dot length. There are various other functions of an array. Dot length returns what? The length of an array, abi? Now we're touching dot map. Dot map is looping through every element in an array once. So what is this function doing? It's timesing every element in an array by 2 and returning it back, creating a new array. So this is a linear function, a linear time, okay? So let's proceed. I hope we are all clear now. We don't have much time and there are still so many other functions we have to look through. So yeah, we have so many map, filter, there are various functions, so you can find time to go through them. Okay, of an array. So let's go through the next one. So this next one should be easy. In fact, I'm expecting everyone to get this. So, but looking at this function, what do you think this function does? Let me start by asking that question. What do you think this function is doing? Look through the function carefully. First, study it. Look at the name. And mind you, see the way this name are correlating to something meaningful. By the time you start writing your own function, please ensure you are using name that links to what you are trying to do. Same with variable name. For instance, now you see let count equals to 0. I already know that they want to use this variable for counting. Something like that. Now I'm saying count zeros from the function name. I'm already assuming that this function is counting zeros. Something like that. So use names that are related to what you are trying to do. Okay. So now, explanation of this. Somebody is already telling me that this function is counting zeros. Obviously, from the name, you should know that. Okay. So I'll just explain the lines of it quickly. So quickly, very quickly. So this function takes an array of numbers, it's returning numbers. It sets an initial counter of 0. It loop through every element in the array and check if they're equal to 0. If they're equal to 0, increase the counter by 1. Then it continues that loop till it's done with every of the elements in the array, checking if they are 0. Then it returns the counter. It's as simple as that. You can run this later to make more sense out of it, but it's not difficult, okay? So basically, this function will continuously increase this counter as far as it finds 0 in this array. So my number one question again is this: what kind of O is this? What kind of big way is this? What kind of time are we looking at here? Is it constant? Is it linear? Is it quadratic? And I expect everyone to get this now. Caller, you and constant. I don't know your problem with constant, so but no problem. You will get this with time. So it's obviously not constant. It's not constant. So is it linear or quadratic? So somebody say it has one loop is linear, okay? Linear, will it return the number of times? It's returning not the number of times, it's returning the number of times it finds zero. That's why we have this counter close to this counter plus plus close to when the number is equals to zero. Okay, it's not returning it's returning only when it finds zero. That's when the counter is close. So we have quadratic, linear because it's one loop, linear. So at least with this, I'm happy to say some of us are getting the hang of this gradually. So what I expect of you to do going for this, go online, check more functions or look at these functions and ask yourself and determine where to place this function. Does it fall under 1 or n square? You will understand the log n from tomorrow, so don't kill yourself. Just focus on these three for now. So this is obviously linear. Okay, it's linear. It's linear. Why? Because we have just one for loop. Just one for loop. So let me move quickly. We have other examples. I'm not going to be wasting time explaining again. I'll just move into the slide. So now, the next one, an array that gets the sum of the elements in an array that do sums. It sums everything in an array. That's what this array does. You can take your time to go through what it actually does. Okay, but I'll just focus on the questions for now. This array function sum, where does it fall? Linear, constant, or quadratic? Another linear function is like they're tired of linear. Okay, linear. And why is it linear? Because it has just what? One for loop, right? So even without understanding how this function works, you can tell where it falls under. Yeah, we are multiplying. We are not multiplying anything here. We're adding. You are tempting me to explain this. Please try and look through it yourself. You will get it. Because there are other things here. So let's go to the next one. So we have log or pairs. Again, I won't bother explaining this, but I need you guys to look at this and tell me where does this fall under? Where does this fall under? So quadratic. So for those that have been saying quadratic since, this is the time to say what's quadratic. Why do we have it quadratic? We have a for loop inside another for loop. So it's not just matter of two for loops. Assuming they are not inside each other, it's still an n. Okay? But as far as they are inside each other, we call it what? There is one inside another. We call it what? Quadratic. That is n squared. Okay? Nested loops. So that is that for this one. Let's look at another example. So let's look at another example. So where does this one fall under now? So we have a function that checks contains duplicates. Okay, that is the name of the function. Yeah. That is the name of the function. Checking for duplicates in an array returns true or false. I think we've even touched this before, if I'm not mistaken. I'm assuming. So, but be that as it may, where does this fall under? Is it linear? Is it constant? Is it quadratic? Nested loop is what's quadratic. As simple as that. Okay. So, I won't waste much time here. I think we have done a lot of examples. So let's go to the. Okay, let's still look at this. I see you even have one example here. I'm not going to waste time here because I assume that you guys know where this falls under as well. But what I want you guys to do is, apart from knowing where it falls under, find time to further understand what we are trying to do. You can see something like multiplying matrix for this one. I don't know if some of us still remember what matrices are, but don't worry. Find time to go through this. Okay. So this one is more of like a two-dimensional array. Let me know add to your problem. Find time to go through this and research. Okay. But my focus for you is, where does this fall under? You are saying two for loop, a for loop inside another for loop, not just two for loop. They're inside, they are nested, so it's quadratic. Okay. So we have touched. We've touched this. We've touched. Okay. Okay. So we've touched various examples for now. So before, what have we learned so far? At least you have understand common patterns for now. I will just ignore the log n. We should be doing more example of it tomorrow. But we should be able to identify constants, constant time. We should be able to identify linear, or we should be able to identify quadratic as well. We should understand now that big O is about scalability, not exactly what timing. How well can your code scale when the number of users increases? Okay. We should also understand that you don't need to memorize this. I will never advise you guys to learn how to cram. I'm not that kind of person. All I need of you is to understand, then just have it in mindset that something exists out there to solve your problem. So for instance now, let me say you want to sort an array, you want to arrange an array. Know that there should be something relating to it. And you should also, the reason why I teach you this way, like I said before now, is to ensure that you know that it's not only, you cannot only work with TypeScript, you can choose other programming language as far as you know how to think through solving problems. So focus on that. So you don't need to memorize, understand. Okay? Because if you memorize, by the time you get to the real world, they won't be giving you these problems you have been showing you so far. So if you don't learn to understand, how do you solve problems you are not used to? So let's proceed. So we also use stuff like data structures like sets. We mentioned sets, even if it's briefly. We also touch mapped in an array. We also touch sorted data to improve performance, stuff like that. Okay. So these are the takeaway for this class. So we're almost getting to the end of the class. Let me use this to make an important announcement concerning the elements. I will just read. So you should be seeing a mail that has this content. You have officially been onboarded on the current learning management system, Canvas by Instructure. Please check your email inbox and your spam junk folder just in case for an invite from Canvas. Once received, do the following: accept the invite, set up your profile immediately, update your full name exactly as you would like it to appear on your certificate, no abbreviation. Include first name, middle name if any, and surname. So this help to ensure your learning records and certificates are accurate. So a link will be shared, I think, yeah, to guide you on how you can, based on what I just explained so far, nothing too much. Okay, so yeah, we'll be having weekly assessment. So the reason why I've not been doing more of this is because of the LMS. But now that the LMS is up and running, we'll be doing more of it. Okay. So some people are still saying quadratic. I'm not asking any question again. So any question, we have 1 minute for question. Any question? No, I'm not expecting any, but any question. Is there any question? Or we can do 2 minutes or maybe a minute. Is there any question? Is it safe for me to assume that we all understood everything so far? Is there any question? Okay, no question from me. Okay, closing time. They're already tired. That's good. So I think that is that. I'll see you guys in the next class. Thank you and have a nice night rest. Thank you everyone.